This is USACO 2016 December Contest Silver, Problem 3 Moocast. Farmer John's N cows, where N is less than or equal to 200, wants to organize an emergency Moocast system for broadcasting important messages among themselves. Instead of mooing at each other over long distances, the cows decide to equip themselves with walkie-talkies, one for each cow. These walkie-talkies each have a limited transmission radius. A walkie-talkie of power P can only transmit to other cows up to a distance of P away. Note that cow number 1 or cow A might be able to transmit to cow B even if cow B cannot transmit back, due to cow A's power being larger than that of cow B. Fortunately, cows can relay messages to one another along a path consisting of several hops, so it is not necessary for every cow to transmit directly to every other cow. Due to asymmetrical nature of the walkie-talkie transmissions, broadcasts from some cows may be more effective than the other cows in their ability to reach large numbers of recipients, taking relay into account. Please help the cows determine the maximum number of cows that can be reached by a broadcast originating from a single cow. First, we'll need to read the input, of course. The first line of input will be N, and the next N lines will contain X and Y coordinate of a single cow, followed by P, which is the power of the walkie-talkie held by this cow. So there will, this line reads, or this input reads that there will be 4 cows. The first cow is at coordinate 1, 3 with power 5. The second cow is at 5, 4 at with a power of 3. The third cow is 7, 2 with a power of 1, and then 6, 1 with 1. Next, the output format will be the maximum number of cows a broadcast from a single cow can reach. The originating cow is included in this number. In this case, a maximum number of 3 cows can be reached from a single cow. And the way we'll need to approach this is by first getting a starting cow. It will be the topmost smiley face. The smiley faces represent the location of the cows, and we need to get the distances between this cow and every single other cow. And we can achieve this using DFS by putting each cow, or finding every cow that this cow can transmit to and starting a recursion at that cow and then repeating the process. And the way to get the distances is by, of course, using the distance formula, which is square root of x2 minus x1 squared plus y2 minus y1 squared. And we can get the distances using that formula and then compare that against the power of the walkie-talkies. And it's important to note that if the results of how many cows can be reached can be changed depending on which cow you start from. So we'll need to test for every single cow here to get an accurate result. And now let's get to programming. This is the programming part, and we'll start by reading the input. We can get the integer n equals integer dot parse and dot read line. And we need to read all of the, I think to do this we'll use a custom class, int x, y, power x and y, and power x equals, and this is just creating the custom class so we can use this to create an array of all of the cows. And this will make it neatly this will allow for like an easier storage of these values. Oops, I misspelled tokenizer. Dot read line cows equals new cow integer dot parse x integer dot parse y, and finally integer dot parse string, or the power of the walkie-talkie. And then we can get to the actual solving part of the thing. It's important to keep in mind that typically the checking if we visited a particular node in the graph is that we check it. How do I explain this? So usually we have one array to check the visited nodes for all of the instances of the DFS. But in this case, we need to create a new instance of this visited array for every time we run the DFS, because the number of cows that can be reached will be different, since the connections between cows are not bidirectional. Each direction has a different strength, so some cows can reach others, while the opposite does not hold true. And I'll actually use BFS to implement this, since it'll be easier to demonstrate in the video. And we'll start by for int 0, and we'll repeat this n times, each for one cow. Q equals new linked list. Q dot add I, and while this is not empty, we'll pull next. Oh, and here is where we need to implement the visited. Then we will iterate through all of the cows and see if we can visit them. B equals 0, b is less than n, b is plus plus. If we visited this place, though, actually here, we'll set this to true. Visited B. Continue. But, or cows, we'll need to calculate the distance between this one and that one, and for that we'll get a function like static double get distance cow A, cow B. We'll set x1 to a dot x, double x2 equals b dot x, double y1 equals a dot y, double y2 equals b dot y. And we'll return math dot square root x2 minus x1 times x2 minus x1 plus y2 minus y1 times y2 minus y1. And this will get the distance, so we can do get distance of cow and cow, and check if that is less than or equal to cows next dot power. Or we'll need to check if it's greater than. And otherwise, we'll add b. Add b. And visited, b will be set to true. And we'll keep a track of how many cows can be reached and keep a maximum tally of this. Max equals math.max, max count. And we'll check if this code works. And sure enough, it works, so we can now try submitting this. As you can see, the program has successfully given a correct answer for every single input case. And that is all.